In this video, we're going to talk about indifference curves and how they can be used to represent a consumer equilibrium. An indifference curve is a diagram that represents all the points that provide a given level of utility. In this diagram, each point on the indifference curve U0 makes this individual just as happy as any other point. For example, points A and B have the same level of utility. At point A, you're receiving a large amount of Y and a small amount of X. At point B, you're receiving a large amount of X, but a relatively low level of Y. Both points, though, would make this individual just as happy. We can use indifference curves to represent the trade-off between any two goods, holding everything else constant. When we drew that indifference curve, we were finding all the points that would make a person equally happy. However, there are points such as point C that lie above and to the right of the indifference curve. One thing we can note is that when we compare point C to point A, at point C the person is getting more of good Y and more of good X. In general, this means that point C would provide a higher level of utility. And we can also compare point C and B, because even though point C has less X and more Y, we know that points A and B provide an equivalent amount of utility. Since point C is preferred to point A, point C must also be preferred to point B. The basic point is that any point that lies above and to the right of an indifference curve will always be preferred to any point on the curve. Similarly, any point that lies below an indifference curve would provide a lower level of utility than any point on the curve. So what we know here is that points above the curve provide a high level of utility. Points below the indifference curve provide a lower level of utility. Now, while we've only drawn one indifference curve here, there's actually an infinite number of them. For example, there's an indifference curve that goes through point C and an indifference curve that goes through point D. In the previous video, we talked a little bit about consumer equilibrium involving marginal utility, and there we had the assumption that we could somehow measure utility. One of the nice features of indifference curves is all that we need to know is that the indifference curve U1 is a higher level of utility than U0, and that U0 is higher level of utility than U2. We don't have to assign specific numbers to this. We don't have to say, for example, that point C would make this person 1.57 times happier than point A. All we need to know is that point C is preferred to point A is preferred to point D, and so on. So when we're talking about indifference curves, all we really need is a ranking of alternatives. And it's easier to imagine people being able to rank alternatives than it is to be able to somehow measure a person's utility. One term that we use quite a bit in microeconomics is the concept of the marginal rate of substitution. The marginal rate of substitution is a measure of the rate at which one good could be exchanged for another. When we have diagrams such as the one we've just been using, we can define the marginal rate of substitution to be the additional amount of good Y, the good on the vertical axis, needed to replace 1 unit of good X. What happens, though, is that turns out to be nothing more than the absolute value of the slope of a tangent line to an indifference curve at that point. When we have a large amount of good Y but a small amount of X, the amount of good Y you're willing to trade off to gain an additional unit of X is relatively high. We can see that because the absolute value of the slope is greater at point A. But as you start acquiring more and more of good X, its value in terms of the amount of good Y you're willing to give up becomes progressively smaller. Another way of putting it is that we expect indifference curves to be convex. What this means is that we prefer a mix of goods to any extreme point, because if one good is relatively plentiful, you're willing to give up a relatively large amount of that to gain 1 unit of the other good. So at point A, because good X is relatively scarce relative to Y, you're willing to give up quite a bit of good Y to gain good X. On the other hand, at point B, because good X is relatively plentiful, you're not willing to give up very much Y to gain an extra unit of X. So at point A, good X is relatively more valuable. At point B, good Y is relatively more valuable. So the slope of a tangent line to an indifference curve is essentially a measure of the rate at which you're willing to trade off one good for the other. Earlier in this course, we talked about a budget constraint, and the basic formula for a budget constraint when we have the two goods X and Y is that Px times X, the price of X times the quantity of X, plus the price of good Y times the amount of Y, must add up to total income, which we label as I here. So that's the budget constraint, as we talked about before. Indifference curves represent a person's preferences. The budget constraint tells you what we can afford. What we're going to assume is that people are trying to get the highest level of utility they can, subject to their budget constraint. So we've added a budget constraint to this diagram containing the indifference curves U0, U1, and U2. Now, any point on the budget constraint is a point that this individual can afford. So, for example, points A, C, and B can all be afforded with this income of I and with these given prices of goods X and Y. Now, if we look at point A, one question we can ask is, are there any points that we can afford that would make you happier than you are at point A? And what we observe is that every point above the indifference curve U2 would make this person happier than they would be at point A or at point B. We find that segment of the budget constraint, the segment of that blue line that lies between points A and B, would all be preferred to point A or point B. So whenever the indifference curve crosses the budget constraint at more than one point, given the convexity of the indifference curves, there's always going to be some interval between those 2 points that would make the person better off. If we look at point C, we observe that the indifference curve U0 is just tangent to the budget constraint at point C. All the points that are preferred to point C lie above the indifference curve U0, but none of the points that would be preferred to point C are affordable. For example, point D would be preferred to point C, but that's not affordable with the existing budget for this individual. Point C provides the highest level of utility this person can afford given their income and the prices of these goods and this person's preferences. A utility maximizing consumer will always choose a point at which their indifference curve is tangent to their budget constraint. So if we want to observe how consumers change their consumption bundles when the prices of goods change or incomes change, all we would have to do is change the budget constraint and find how we move from one point of tangency to another.